Assalamu alaikum. In this series, Mr. Omar will guide you through some practice problems to cover all items included in the coverage issued by Emirates Schools Establishment, E.S.E. This is part 3. Have a fruitful time.
السلام عليكم ورحمة الله وبركاته. بسم الله الرحمن الرحيم. Welcome back. We are now in part 3, question number 6, our goal number 6. First one, a 423 Newton horizontal force, this is the force F, and it is applied force, so it is Fa. It is horizontal, accelerates a go-kart and its driver from 10.4 meter per second, so it is the initial, to 17.9 meter per second, this is the final. In time interval, it is 5 seconds. On a horizontal frictionless, there is no friction surface. What is the mass of the go-kart plus the driver? It is a simple situation where we have a cart with a driver, and this is a drive with a force Fa. There is no friction. We have the weight under, and here we have the normal force. The normal force and the gravity will not affect the acceleration. Now, according to Newton's second law, F net on the x-axis equals m times a. Now, if we need to find m, we need the acceleration and the force. We have the force, it is 423, and here is the mass. How much is the acceleration? If you see in the question, we have V final, V initial, and time, so we can use V final equals V initial plus AT. V final, it is 17.9 equals V initial 10.4 plus acceleration times the time 5. From here we have the acceleration equals 1.5 meter per second square here. Then we will get the mass as 282 kilograms. Now for question number 2. The previous problem, we solved if we slope the surface by 37 degrees above the horizon, how much is the least magnitude of a force needed to pull the system to the top surface with the same acceleration in the problem? So we have here slope, inclined surface with an angle of 37. Now put the object on the surface, x-axis parallel to the surface, y-axis normal to the surface. The gravity toward the center of the earth. This angle is 37, and we can make resolution for the gravity Fgx and Fgy. We have here a normal force. Now the question asks me to find the least magnitude of force needed to pull the system to the top of the surface. So we have here a force that's needed to pull the system up the inclined edge. Least force means the force is parallel to the motion. That is the meaning of least force. And we need the acceleration to be the same as in the previous example, which is 1.5 meter per second. Now again, we need to apply Newton's second law. F net, the x-axis, equals m times a. On the x-axis, we have two forces, Fgx to the right and Fa to the left. So Fgx is positive and Fa to the negative. So here we have Fgx minus Fa equals m times a. Now the motion is up, so the acceleration should be in the negative direction. Then if we need to write the acceleration in vectorial notation, if a in the x direction, it is minus 1.5 meter per second square. Now we need Fgx, which will be Fg sine theta. Now we find the mass 282 mg sine theta. So for Fgx, put mg sine theta. Here mg sine theta minus Fa is unknown, equals m times a. Then Fa should be equal to mg sine theta minus m times a. Now you can substitute or take the m as a common factor. G sine theta minus a. M is 282, G 9.8, sine the angle 37, minus acceleration as we discussed before, it is minus 1.5 because it is in the negative x direction. Use the calculator to find the answer. It is 2086. If we round it to 3 digits, so it will be 2090 newtons. Now we need to resolve these two equations but with a friction. So suppose here that we have a kinetic friction of coefficient of 0.195 and resolve the question. For the first one we have a horizontal surface, and for the second we have an inclined surface. Now first, for the horizontal surface, this is the surface and this is our object. X-axis parallel to the surface, y-axis normal to the surface. We have the gravity on the negative y-axis. Against it we have the normal force. Now this is the force, applied force, and this is the motion to the right. Now since there is a coefficient of friction, then we have friction force opposite to Fa, opposite to the motion Fk. First of all, on y-axis, apply the condition of equilibrium. F net on the y-axis equals 0. We have the normal force minus Fg equals 0. Then N minus Fg, it is mg equals 0. Then N equals m times g. Since we have the normal force, we can find the friction, kinetic friction. Fk equals mu k times N. So it is mu k m times g. We don't have the mass, so we stop here for friction. Now on x-axis, apply Newton's second law. F net, the x-axis equals m times a. The forces on the x-axis are Fa to the right and Fk to the left. So we will put here Fa positive and Fk negative equals m times a. And remember that a is equal V final minus V initial over t, which is 1.5. We solve it. Now Fa, it is given in the question, it is 423. So we have Fa equals Fk plus m times a. Fk, it is mu k mg plus m times a. Take m as a common factor, mu k g plus a. This is Fa. We need m. From this, m equals Fa divided by mu k g plus a. Substitute to find m. M equals F is 423, mu k 0.195, g 9.8, plus the acceleration is 1.5. And the answer will be 124 kilogram, which is less than 282. And it is obvious because we have a friction, so some of the force will exert it to manage the friction. So the mass should be lighter than the one before to achieve the same acceleration with the same force. Now we need to resolve this question again, but on an incline, and we need to find the force, the least force needed to pull all the way to the top of the incline with the same acceleration. Now, for the inclined surface. This is the inclined surface. Here we have the angle, it's 37 in the question. And here is our object, x-axis and y-axis. Here is the gravity. This angle is 37. This component Fgx and this one is Fgy. Against Fgy we have the normal force. Now the least force needed to pull it to the top of the incline, it should be because it is the least force, it should be parallel to the motion or to the surface. This is FA. And the motion is upward. So the friction should be to the right. This is Fk. Now again on y-axis, we have F net. The y-axis equals 0. Then N minus Fgy equals 0. That means N equals Fgy, which is Fg cosine theta, and Fg, put in your mind, it is M times G. Now the friction force, we have the normal force. The friction force is mu k times N. Again, it is the same as the same before. Mu k times N, and it is mg, the gravity, cosine theta. Here we can put the numbers and get Fk as a number, but I will continue with the symbols. After that, I will find the value at that. Now, on x-axis, apply Newton's second law. F net x equals m times a. On the x-axis, we have forces Fk and Fgx to the right, so they are positive, and Fa to the left, so it is negative, and the motion to the left with acceleration, so the acceleration is also negative with the motion. Then put here Fk, it is positive, Fgx also positive, but Fa it is negative because it is in the negative direction, m times a. I need Fa. Fa will be equals to Fk plus Fgx minus m times a. Fk it is mu k m g cosine theta, زائد Fgx it is m g sine theta minus m times a. We can factorize m. Here we have mu k g cosine theta plus g sine theta minus m times a. Substitute your numbers. M is 1.124, mu k 0.195, g 9.8, cosine, the inclined angle is 37, plus 9.8 sine 37 minus 124 times the acceleration is 1.5, and the answer will be, sorry, we forget that the acceleration is negative. Very important, because the direction of motion is negative and the acceleration in the same direction. The answer is 1106.6. If you have 3 significant, it's 1110 in Newton. Now for goal number 7, if you please, read this carefully to understand everything about the static friction and kinetic friction. You will find in the description box a link for the paper that contains these this information and all answers of all the questions. So don't forget to read this carefully and understand it well. We use everything that in the previous questions, but you need to memorize it again. Now we have another question here to practice our knowledge about this graph and the friction force, static and kinetic. The shown graph illustrates the relationship between a changing horizontal applied force acting on an object and the friction forces. The object rests initially on a horizontal surface. Answer the what is the magnitude of the gradient or the slope of the line from A to B? The slope from A to B is 1. Why is that? Because from A to B we are in equilibrium. This line illustrates the relation between Fs and Fa. Applied force equal the friction of static before motion. As you increase Fa, Fs will increase by the same factor. So then the slope of this line from A to B, it is only 1. Then slope equals 1. Slope of AB equals 1. How much is the maximum magnitude of the static friction force? I need the maximum static here. This number is Fs maximum. As we mentioned here, at all time before motion, the static friction equals Fa. Here, Fa it is 14, so the Fs maximum is 14. So Fs maximum equals 14 Newton. If the coefficient of kinetic friction is 0.25, find the coefficient of static friction. Now, coefficient of kinetic friction is 0.25. How can we get from it coefficient of static friction? We know that Fs maximum equals mu s times the normal force, and Fk equals mu k times the normal force. If we divide two equations on each other, we will get Fs maximum over Fk equals mu s n over mu k n. We can cancel n with n since the normal force is not 0. Divide by n. So this is the equation. I need mu s. According to this, mu s equals Fs maximum over Fk multiplied by mu k. Now, Fs maximum from the graph, we find that it is 14. And Fk from the same graph, this number indicates the Fk. This is Fk. It's the friction while the object is in motion. So it is 7.7. Here we have 7.7 times 0.25 for the kinetic friction. So 14 times 0.25 divided by 7.7. The answer is 6 over 11. Approximately 0.455. No units. So this is part C. Part D, if we apply a force of 18 newtons on this object, find its acceleration. The mass is 5 kilograms. Now, for part D, FA equals 18, which is larger than Fs maximum, so there is a motion. Then we have acceleration, not to be 0. If Fa is less than Fs maximum, the acceleration should be 0, no motion. Now apply Newton's second law. F net equals ma. Fa minus Fk equals m times a. We need the acceleration. Fa is 18. Fk from the graph is 7.7. The mass is 5 times the acceleration. Then acceleration will be 18 minus 7.7 all divided by 5. So the answer is 2.06 meter per second. E, if the applied force decreases from 18 to 10, find the new acceleration. We will use the same formula. F net minus Fk equals m times a. Now F is dropped to 10 minus 7.7 equals 5a, and the acceleration will be 10 minus 7.7 all divided by 5 is 0.46. If the applied force becomes 6 Newton after that, how much is the acceleration? Again, F net minus Fk equals m times a. Now the acceleration will be F net 6 minus 7.7 over the mass is 5. The answer is minus 0.34. Now we have deceleration. Now the speed will be decreases. When this object at rest and you apply a horizontal force of 6 on it, how much is the acceleration? G. Fa equals 6 Newton. It is less than Fs maximum, and the object at rest. So the object remains at rest in equilibrium. That means the acceleration should be 0, no motion. I hope you find good information in this question. It's a lovely question, and it is one of the most fruitful questions that I put this year. Question 7. What coefficient of friction is required to stop? To stop means V final equals 0. A hockey puck sliding at 12.5 meter per second, this is V initial. Over a distance of, this is delta x. Coefficient of friction. Now, we have a horizontal surface. This is the buck. This is x-axis, and this is y-axis. On y-axis, we have the weight and the normal force. From that, F net on the y-axis should be equal 0 because we have equilibrium in the vertical axis. Then we will get that N minus Fg equals 0 and N equals Fg, which is M times G. Now Fk equals mu k times N. Then Fk equals mu k, and it is M times G. Now suppose the motion is to the right, then the friction would be to left, and there is no applied force. Then we can apply Newton's second law. F net on the x-axis equals m times a. This is a Newton second law. We have only Fk in this direction equals m times a. Now the friction is to the left, so it is negative mu k m times g equals m times a. Cancel m with m, then mu k equals minus a over g. Now all we need to find the acceleration. G, it is 9.8 minus, we need the acceleration. To find the acceleration, use the information in the question, V final, V initial, and delta x. To do so, use some space. For the acceleration, V final squared equals V initial squared plus 2a delta x. Isolate the acceleration, should be V final squared minus V initial squared over 2 delta x. Find its value. V final is 0. V initial 12.5 squared. And the delta x is 60.5. So the acceleration is almost minus 1.29 meter per second square. This number is rounded. We have 9.29. If you make the division, it is 0.13 without unit because it is option of friction. Also, from the book, page 125, question 4.72. It's a good question. Now, a skydriver of mass 83.7 this is the mass, including outfit and equipment, falls in a spread eagle position having reached terminal speed. His drag coefficient is 0.58. What is the symbol of drag coefficient? Here, let me make it clear that we have drag constant and the drag coefficient. Drag coefficient, its symbol is CD. Drag constant, the symbol of it is K. How can I distinguish between them? CD has no unit. K has a unit, and the unit depends on the nature of the force. For example, if the drag is proportional to square of velocity, then we will put for the following object mg equals k v squared. Here we have kilogram meter per second square. Here we have k meter squared per second square. Cancel this with this with this. So the unit of k for this situation is kilogram per meter. But it may be differ from situation to other situation as drag force. So to distinguish between them in the question, K has a unit, CD has no unit. Then here the drag coefficient is 0.587. This is CD. If you be confused in the exam, no unit, it is CD. And the surface area that is exposed to the earth is, this is the area, A. How long I need the time? It takes him to fall a vertical distance, this is delta x. And we have the density of air, it is rho. Now, for falling object with air resistance as a drag force, we know that the drag force, F drag, is proportional to v squared. And it should be equal to drag constant K v squared. At terminal velocity, which is constant by the way, F drag should be equal to Fg. In this way, we have equilibrium because two opposite forces and equal to each other. The F net equals 0, so the acceleration is 0. Now put your numbers K v squared equals m times g, and by the way K is related to the drag coefficient like this. K equals 1/2 CD area times rho for the air. So put all of these in this equation. K 1/2 CD A rho v squared equals m times g, and from here you can get the velocity. The velocity v squared equals 2mg over CD A rho. CD A rho, and if you take the square root, the velocity should be the square root of this quantity. Now, because the velocity is constant, it is terminal velocity, we can put Vt equals x over t. That means t equals x over v. X over square root of 2mg over CD A rho. X square root CD A rho over 2mg. It is down, we get it up, so invert it. Now substitute your numbers, that's it. This question will, if they want to bring a question on the drag force, they will bring the same as this exactly. Maybe the numbers is different. So now the mass is 38.7. All we need to put only the numbers. T equals, the distance to be traveled is 296.7 square root of coefficient of a drag, that is 0.587, times the area faces the stream is 1.035 times the density of air is 1.14 to the mass of the diver is 83.7 and G it is 9.8. So the most important thing is to derive this equation, or you can easily memorize it. Or derive as I explain here. Put the numbers in the calculator and the answer would be 6.0963291, almost 6.10 seconds.
I hope that this video has enriched you more. In the description box below, there are links to both a PDF document for answers and the other videos in this series. This is the end of part 3. See you in part 4. Salam.